Hi, my friend. My name is Erkan Suçular, CEO and founder of International DevOps Academy, where it's our biggest duty and pleasure to teach you DevOps as good as we can. And today I am here again with a very exciting lesson, and without further ado, let's get started. So it's great that everything is already shared with you now. I'm quickly making my screen a little bit smaller so we will have a better and larger space to discuss. Okay, I think this size is good enough. Today's subject is basically how you should build DevOps organization and design your software architecture. So it's a very interesting subject. The reason is being, the organizational setup and the configuration you already have, or the way you will change it, will basically directly impact how you get your software built, and therefore the organization as well as the architectural setup you are going to have in your DevOps initiative is one of the critical subjects which is going to impact the success or fail of your DevOps story. Therefore, we will be basically covering today what kind of team structure you should have in place and what kind of architecture you need to get set up so your DevOps initiative will be a great success story like many other successful companies. So basically, according to Conway's law, organizations which design systems are constrained to produce systems which are copies of their own communication structures. In other words, your software cannot do any better than how efficiently your teams communicate and interact. Therefore, how you structure your teams will surely impact your software architecture, IT, and finally, your business performance as well. Having said that, how you configure your organization defines basically what kind of software you are going to get. Most companies, probably including your company too, compartmentalize their software delivery organizations in a number of teams, and they end up producing their software architected with the very same number of layers. The controlled experiments have also proven that when an organization of 6 teams was asked to build a software, their teams came up with an architecture of 6 layers. When another organization with 3 teams was asked to build the very same software, they came up with an architecture of 3 layers. In fact, there are many similar examples. So this is a very funny example because the more compartments you have in your organizations, then this means the more layers you are going to get in your software, and obviously this will make deployment complex, dependency management complex, and maintenance and operations, everything will be more and more cumbersome. Therefore, think twice or 3 times before you decide what kind of compartments you are planning to get your IT organizations, you are planning to set up in your IT organizations. And DevOps will have some suggestions to mitigate this issue, to rectify this issue that I'm going to come in a minute. So here is an example of how a renowned insurance company started their DevOps journey and how they improved their status. So let's have a look at this. A renowned insurance company with 86,000 employees worldwide was coincidentally structured in 2 major functional teams for one of their IT organizations, which delivers the backend to manage their customers, contracts, invoices, and services. One of these functional teams was oriented in Java programming language, and the other functional team was oriented in PL/SQL stored procedures. Furthermore, they were dependent on organization-wide and centralized IT operations, database admins, IT infrastructure, IT networking, IT security, and IT quality assurance service desks, which made their lives even more challenging to be able to safely and quickly deliver their software. The other challenge of this organization was that although the teams were separate in their architecture, they couldn't competently separate business orchestration logic in Java from data access logic in PL/SQL. They delivered hundreds of features, each feature being a spaghetti of Java and PL/SQL codes. Therefore, every change and new feature request required tens of handovers from one team to another, and they resulted in long waiting queues and lead times to get even minor changes done. Moreover, in this complex environment, as overall impact of even minor changes was very difficult to foresee, they continuously broke existing production features and caused downtimes, which also required long lead times, escalations, rework, and stress to resolve. To recover from this modus operandi, these two functional teams merged into one single product team. They gradually redesigned their software by converting their data access layer into a set of API functions. In addition, they built a new business system completely decoupled from the internal dynamics of their data access API. Even in its early stage, this initiative improved the team morale because both Java and PLSQL experts started working for the success of their joint product team instead of motifs of their past functional silos. As they built a loosely coupled architecture, now the impact of changes are easier to identify. And changes are easier and quicker to implement, and defects are more straightforward to locate and fix. As a result, average lead time of new features reduced from 4 months to 3 weeks. An incident queue of the team is now almost empty, so they profit from this free capacity by further reviewing, refactoring, and improving their code base. So this organization, as explained, basically merged two teams who used to work independently, and once these two silos merged together and started working for the same organizational goals by using the similar ticket management, issue resolution, or project management tools, they basically improved the overall performance very dramatically. This is a very exemplary use case. And now I want to talk about a little bit matrix organizations, functional teams, and the illusion of cost optimizations, because this is the most of the companies' current situation, by saving money. So basically most companies create bigger trouble, reduce employee morale, and also reduce the quality of software, which in the end also reduces the business performance and the quality of the services and products that these companies offer. And in the end, the overall impact is neither cost optimization nor saving, and also nor contribution to the customer service and product. Therefore, I want to little bit give some background, some ideas how deep this problem is, and now we will come into the suggestion from DevOps how we can get this problem sorted out. So your companies are organized with a number of functional teams around various different subject matter expertises such as databases, networking, operations, information security, quality assurance, release management, product management, project management, and so on. So imagine there are so many different teams working to deliver a software, which is already mind-blowing. Project teams are built by people from different functional silos. In this matrix project organizations, which attempt to deliver business products and services, project managers are usually responsible for getting something delivered, and product managers are responsible for ensuring that the correct thing is being delivered. Good luck. And your problem in this organizational configuration is that functional teams have no to little understanding about the extent of the work they contribute. In extreme but often typical cases, your functional teams neither care the big picture nor the overall and business throughput of the product and service they build and contribute. What they care is to make sure that none of their doors are left open after projects will go nasty and everyone starts to finger point, and all escalations are flying around between IT, inside IT, or among IT and the business organizations. So functional teams usually have to manage long queues of tickets. They usually require long lead times to support your project. Because projects fight for functional resources, escalations are the only way to get quick attention for your own project. Escalations or escalations obviously pollute the working climate and trust between the teams. Multiple handovers from one team to another, delays, quality issues, reworks, bottlenecks, and stress are now part of our daily job. This is because matrix organizations are not meant to do any better than that, as long as they delays, functional organizations are probably even more expensive than any other random reorganization you can ever imagine. In addition to this, if your organization has already managed to outsource some of its vital functions such as quality assurance and IT operations to geographically remote locations with time zone difference and everything, then your IT organization must be now barely surviving to safely deliver and fulfill demands which are critical for your business continuity. This is actually a big problem. How does DevOps solve this? And the answer is, the short answer is with product and service oriented teams. Now we are going to cover what product and service oriented teams are and how you can set them up in your own business and IT ecosystem. In order to solve this problem, DevOps suggests you to switch gears from cost optimization illusion of functional teams and matrix organizations to DevOps valid and proven speed optimization. In fact, done correctly, DevOps will anyway enable you to save costs while you and your team quickly and continuously deliver. For you, DevOps suggestion is product and service oriented teams. Product and service oriented teams are independent, cross-functional, autonomous, self-sufficient and usually small teams which are able to cover all phases of software engineering lifecycle of given product and service, including architecting, designing, coding, testing, experimenting, deploying, operating and maintaining software. So here what I want to emphasize is these are not temporary project teams to deliver a product or service. These are basically permanent teams to be fully responsible during the complete life cycle of a product and service. I know projects such as a self-care project, and then the version 1 is done by a team, and then version 2 is done by another team, and version 3 was done another team, and all this handovers, the transfer of knowledge, and along the way, all the critical information was lost because one team was not in the same place to manage the same product. Actually, the cost of this is very huge. Therefore, DevOps suggested if you're product X, let's make the same team responsible from requirement assessment to coding to testing and then deploying and then maintaining and then the next versions and everything. Make this team responsible to handle the life cycle of that product. So this is the the major idea, major differentiator here. Instead of temporary project teams, you set up permanent product or service teams. And as I said, these teams are also, maintaining and operating this software. And you understood this correctly. I am talking here that the same team who developed this software will be also in charge to maintain and operate the software in its own production system. And here the way you should think with DevOps is that who else can operate and maintain software better than their own creators? Of course, no one else. Only the ones who designed and developed the software can now know how to best operate and improve, add new functionality to the software. And therefore, it's no surprise that most successful DevOps teams at champion DevOps organizations such as Amazon, Netflix do not abandon their products and services once they release them. They are also in charge of operating and maintaining their software in their own production systems. Here we have a small chart, and in this chart, on the left half of this chart, you see that there are business units which are completely separated from the feature teams, and feature teams are responsible, such as one team is responsible from a certain aspect of team, another team is responsible for the other type of functionality, and then here you have functional silos such as server team, network team, database team, and virtual management team. And to get any work done, you should follow the spaghetti in these organizations, and of course, to get attention from a subject matter expert, you need to escalate the situation or wait their ticketing and service management queue, which takes basically very long and tedious lead times to deliver any work. But on the left-hand side, you see the product teams, and each team is responsible for a certain product. And once they basically deliver them, they basically operate this software in the platform as a service environment or infrastructure as a service environment of this company. And then users basically take the benefit of this software. And this is a very dramatic shift that the champion DevOps organizations managed to implement very well. And after having said that, the understanding from the organizational side, the understanding should be that the organizations does no longer finance temporary projects, but the financing also must be done based on products and services that your organization wants to release. And to make its business performance flourish, your organization does no longer finance temporary projects whose tangible business outcomes are not trivial to evaluate in long run. Now with DevOps, your organization finances its own mission, its own purpose, and its own products and services associated with this mission and purpose. The success of your teams are now assessed and evaluated based on their IT and business performance, based on return on investment within their particular business domains where they serve their products, services, and microservices to their internal and external clients. Your teams now act like owners of products and services they create and provide instead of merely being members of functional silos who do not pay much attention to business outcomes. How can you build your DevOps teams and software architecture? DevOps does not, of course, suggest you to break and reorganize all ongoing projects at your organization in one go. A non-disruptive but still impactful way of adapting your teams for DevOps methodology is to inject functional experts into already ongoing project teams. Once your teams get functional experts, here the idea is instead of asking a certain, silo, let's say a database team to get, to support them, with database expertise, or security team to support them with security expertise, or the operation management team to support them with the help of, operation, etc. You already inject these experts in the project teams in the beginning. This is the easiest way to first mimic the product team. Instead of, getting help to these service teams, embed some experts to your already ongoing project teams. And once your teams get these experts in their desired domains, and these domains can be, quality assurance. Now you embed the quality assurance expert already in your project team instead of asking help from an external quality assurance team, or information security, database, networking, servers, operations, and so on. Again, you bring these experts into your own team. Then you can expect these teams who already get the subject matter experts into their own, under their own roof. Then you expect these teams to independently and self-sufficiently design, deploy, and maintain their software products and services. And in this new product and service-oriented DevOps teams, availability, quality, performance, information security, and compliance are now everyone's daily job instead of outsourcing these jobs to external teams. How can your teams build high-quality, highly available, secure software applications which are able to cope with stress and load demanded by your clients if the teams never pay attention to these non-functional requirements until they really finish their design and deployment? How good can external experts judge and validate the security and quality of your software applications without being involved at any software engineering stage of your products and services? This is why high-performer teams rely on external subject matter experts only to get consultancy, but they still fully own all non-functional requirements at every stage of their software engineering lifecycle. A simple example is, you build your systems with built-in quality, with built-in analytics, built-in security, built-in compliance. You start thinking all these aspects even in the very early stage of your project, instead of you do something You design a project and then you hope that the security expert, an external security expert on external security silo reviews your application and then stamps that okay, this is a secure application. No, this is not the way how the DevOps works. You already have the security expert in your team to validate how your application is designed, whether it's compliant with the security standards, or if you need to comply with certain performance benchmarks, let's say 10,000 requests per second, then you need to make sure that once you design your servers or architecture, you need to make sure that you can already comply with this requirement, with this benchmarks, instead of hoping that what you have done in the beginning compliance with this desired outcomes. So you should be planning this in the very early stages of your engineering life cycle. And there is an alternative you can consider. One exceptionally successful DevOps organization, which still heavily uses functional teams in combination with product and service-oriented teams, is Google. At Google, DevOps teams and functional teams see their organizational mission with their products and services as a shared goal. Functional teams build blueprints such as templates, checklists, application skeletons, etc., and self-service systems such as provisioning, configuring servers and networks to make sure that they never become bottleneck which slow down DevOps product and service teams. Functional teams at Google collaborate and support product and service teams at early stages and software engineering lifecycle. They constructively perform peer reviews of designs, codes and tests, and they continuously provide consultancy to DevOps product and service teams. Google's understanding is, again, they have product teams, service teams, but these teams does not constitute all expertises. There are some service tasks in some certain subject matter expertises, but this service tasks basically highly collaborates with the product and service teams, and therefore Google could basically break this barrier in a functional environment. But this is a very exceptional way. But there are also other fundamental aspects why Google became successful with DevOps. They have a methodology which is quite untraditional, which is this: once a product team developed the project, until they deliver the project to the operations team, they have to operate this in production for 6 months. This is also another aspect that Google's engineers are highly talented, and they could basically solve most of their questions that they could also collaborate with the service desks by also themselves, say the database or networking or security and compliance. They basically constitute all these talents in these teams, and therefore the product teams also strive to reduce the dependency to the support desks, because in the end they will be responsible to operate the product in the production systems for about 6 months period. This is also another strategy that DevOps, how Google uses DevOps in their own organization. We will also touch this in the upcoming lessons together with you. And the next item is, how big should be your DevOps team? The ideal size for a DevOps team is 5 to 10 people. Again, this is not a stone-grained fact. You can have a DevOps team for 4 people or 3 people if you want to, or you can have a DevOps team for up to 15 or 20 people. There are, of course, some downsides or upsides of doing or giving these decisions. We will also touch them briefly. But again, 5 to 10 people is not a stone-grained fact that you should stick no matter what. So such a limited team size reduces complexity of communication and alignment with your team. So here clearly, if you have a bigger team such as 20 people, then the communication will be more cumbersome in such a team. Furthermore, your team lead and team members do not spend and invest much time with errands and overhead, as the team size is smaller. This also keeps the size of product and service your team is responsible for up to a certain limit, which further reduces the complexity, maintenance, operations difficulty of software applications. Every team member in such small teams sees the big picture, and everyone collects a little bit of leadership experience by becoming part of a crucial mission for your organization. Your team lead works with upper management to understand goals and then translates and transfers these goals to your team members. What if your product and service can no longer be handled by a team of up to 10 people? Then your solution is to spin out a new product and service and to build another DevOps team which takes it over. Here you shouldn't conceive product and service concepts only as entities served and provided to external clients who pay for them. But also you can freely build internal products and services or so-called microservice APIs and their respective DevOps teams for your internal clients. For instance, if your billing system becomes too big for a team of up to 10 people, then you should spin out another DevOps team which basically which takes over database access API. Maybe another team, another one which takes over online payment API. Then maybe another team which takes over which takes over batch processes. Of course, all these teams should be using a common code repository and joint deployment pipeline to ensure continuous integration, quick delivery, and success of their organizations. As you already know, in a tightly coupled architecture, small changes in one application can eventually cause many adverse effects for numerous workflows. Therefore, products and services and microservice APIs in your architecture must be loosely coupled. Each DevOps team must be only responsible for one piece of loosely coupled architecture. Each DevOps team can independently design, develop, and deploy their software. Early alert mechanism, built-in deployment pipeline should automatically and rapidly inform DevOps teams about potential adverse effects and any code check-ins causes. How can such small teams up to 10 people can self-sufficiently handle all phases in software engineering lifecycle from architecture to operations by themselves? To manage this, DevOps suggestion is you should encourage everyone in your team to become a generalist engineer, a generalist full-stack software engineer. You should encourage and enable them to continuously build new skills. You should only hire team members or select team members for your own team who are eager to learn and grow regardless their effective level of know-how and experience. You should strictly avoid people who expect to be evaluated in a fixed set of roles and responsibilities. You already know that neither your organization nor your products and services remain fixed. Then why would you choose people to be evaluated and to continue on the fixed set of roles? You should pick up people who are open-minded to develop themselves and reach better results and contribute to the success of their organizations. And the demand is changing every day. Therefore, we should be choosing our employees. We should be building our team by preserving this open-mindedness and flexibility. So today's lesson is very interesting to give you an idea what kind of organization we should have and what kind of architecture we should build. And in this video lesson, so we basically covered today for you suboptimal outcomes of matrix organizations, functional silos, and DevOps solution to address them. DevOps suggestion for you is to build product and service and microservice API-oriented small teams up to 10 people. These DevOps teams should constitute generalist full-stack software engineers which are able to self-sufficiently cover all phases of software engineering lifecycle from design to maintenance. DevOps relies on loosely coupled service-oriented architecture in which every DevOps team owns and operates one piece of your loosely coupled architecture. So we are now in the end of this video. After you watch this video, I want to hear your feedback and please let me know if you like this video or if you want me to cover other lesson. I will be happy to read your feedback and to answer it by myself. And for now, I wish you a great day and I really hope that you enjoyed this video. Take care and have a great day.